Hi, everyone. Thanks for joining us today. We're going to wait just a few minutes before getting started to allow folks to get logged in. Welcome to today's webinar, Achieving SLO Success with Golden Signals and Reliability Testing. Our presenter today is Andre Newman, Senior Reliability Specialist here at Gremlin. Before we get started, though, I have a few housekeeping items to cover. First, today's presentation is being recorded and will be emailed to each of you as soon as it's available. Second, we will be doing a short Q&A session at the end of the slides. We encourage you to put your questions in the Q&A panel throughout the presentation. And with that, I'll turn things over to Andre.
Awesome. Thanks, Jeannie. Hey, everyone. Thanks for joining. Like Jeannie mentioned, today I'll be talking to you about achieving SLO success with golden signals and reliability testing. I'll start by talking a little bit about what SLOs and SLAs are, what golden signals are, how you can link them together, and then how you can validate them and your services using a practice called reliability testing. And then after that, we'll do a quick wrap up and then leave some time for Q&A. So before we get started, I'm sure many of you joined this webinar because your team already has SLOs and SLAs in place that you need to adhere to. If you do, or if your team is actually already using golden signals, feel free to leave a comment into the chat box. Part of that is just that I want to take a moment to commiserate with all of you. SLAs and SLOs are really hard to do right. It's hard to accurately measure service quality, reliability, and performance. It's hard to work with the business side to figure out what matters for customers. And it's even harder when you fall short and have to respond to a violation or missing one of your SLO targets. But we at Gremlin think that that doesn't really have to be the case. There are tools and practices out there that can help you with better managing, understanding, and adhering to SLOs. And part of this webinar is I'd like to show you one of those approaches. So again, my name's Andre. I'm a reliability specialist here at Gremlin. I personally love talking about reliability in modern systems, especially with these complicated distributed cloud systems that we're running now. It's one of the main reasons why I joined Gremlin. So if you have any questions or just want to chat, please feel free to reach out to me on email or Twitter, and I'll be happy to talk to you. So a quick overview of what we're going to be covering. So first, we'll set the groundwork around SLAs are and what the golden signals are. We'll talk a bit about how to tie the golden signals into your SLOs, how to tie them into your reliability practice, and then we'll dive into Q&A at the end. So first, let's just set some groundwork on what are SLAs, SLOs, and SLIs. A lot of you are probably already familiar with these terms, but just to sort of set the baseline understanding, I just wanted to go through and define these real quick. So the service level agreement, or SLA, is essentially a business contract that guarantees a minimum level of quality of performance from a provider to its customers. Service level indicators, or SLIs, are the sort of individual metrics that we use to measure adherence to an SLA. They're sort of the foundation of an SLA, right? They're the numbers and outputs from our system, from our observability tool that we need to track to ensure we're meeting our SLAs. And then sort of bridging those two ideas together are service level objectives, or SLOs. These are the ranges that our SLIs have to fall within in order for our SLA to be considered healthy. So SLIs are the individual measurements. SLOs are the ranges that those SLIs must fall in. And if our SLOs look good, then our SLA is good. And for engineers, SLIs and SLOs are usually the most important because they directly translate to system metrics and thresholds. And they're typically what you would put into your monitoring observability tool to make sure that you're tracking towards them. But still, though, they only make sense in the context of SLAs. So defining these and getting these set up is typically a business-wide task that involves both the business professionals and engineering teams as well. So why are SLAs important exactly? Well, again, they're primarily business tools. They're legal contracts between business leaders and customers that guarantee a certain level of service. And if that guarantee isn't met, customers are usually entitled to refunds, discounts, or some other type of reimbursement. And again, SLAs are typically set or at least initiated by business leaders, but it really comes down to the engineers to make sure that their systems are meeting the promises defined in the SLAs, and that you also have the ability to track that to make sure that you're meeting your SLAs. Now, again, SLAs require collaboration from both sides of the businesses. Both sides need to understand and agree on the terms and how to measure adherence, or else bad things could potentially happen. And what are those bad things that you ask? Well, there's less revenue. There's a risk of less revenue due to customers requesting refunds or reimbursements, or for our services having downtime. We lose a bit of that customer trust that we work so hard to build. We get hits to our brand reputation that we also worked hard to build. And then our engineers get demotivated. Right? Nobody wants to feel like they missed a target or that they failed at something or that their systems broke. So any chance that we miss our SLO targets, there's also the chance for engineers to get disheartened. And really what all these things have in common is that they lose money. And frankly, businesses hate losing money. So SLAs are a great tool for building customer trust, but as long as you can adhere to them the majority of the time. And I'll dig into a bit more about that later for tactics about how you can do that. First, I just wanted to quickly cover, well, not quickly, I wanted to cover what are the 4 golden signals, and again, what do they mean and how do they relate to SLAs? So the golden signals are specifically 4 metrics that are meant to represent key attributes of a system. More importantly, these are attributes from the perspective of our users and how they interact with our systems. And they tell us things like, how well is our system performing? How close is it to its maximum capacity? What errors are it generating? And how many users can it reliably serve before failing? And the 4 metrics themselves are latency, which is the amount of time it takes for a system to respond to a user request. Traffic, which is how much your service is in demand, like how much are your users actively using it. There's error rate, which is the rate of requests that fail either explicitly, implicitly, or by an application policy. And then there's saturation, which is how much computing resources, like hardware resources, is your system utilizing. And typically, this is measured in CPU memory, but it can also include things like disk space or even network bandwidth. And if you've never heard of these before, you're probably wondering where they came from. And no, we didn't just make them up, although honestly, I'd love to be able to be the one to take credit to come up with this idea. But it actually comes up with from the Google SRE team. They define it in their Site Reliability Engineering Handbook, which if you haven't read it, I highly recommend. It's available online for free at sre.google.com/srebook, and specifically from chapter 6. And it has a ton of great info in it. It has an entire chapter dedicated to the golden signals and observability. And again, this is from Google. They literally wrote the book on SRE. So I definitely highly recommend giving this a read when you have some time. Of course, since golden signals are metrics, they do require observability and they do require integration into your observability tool. But the good news is that they're so common that a lot of monitoring tools already have pre-made templates that make them a lot easier to set up. So like as an example, at Gremlin, we use Datadog a lot, especially for our test systems. So a lot of our dashboards just have the golden signals already set up. Now, ideally, each service in your environment should have its own set of golden signal monitors, but that can easily get into the hundreds depending on how many services you manage. So at the very least, just start with the services that directly impact your SLA, set up the 4 golden signals for those, make sure that you have your alerting and warning thresholds set up so you're able to stay ahead of any potential changes or violations to your SLO. And then from there, just expand out until you can build it out to all of your different services. Okay, cool. So Google came up with a few metrics and gave them a cool name called golden signals. What does that have to do with SLAs? How does that tie back to really the focus of this webinar? Well, again, golden signals are supposed to be the most important attributes of a service as they affect your users. And that sounds like a lot like SLIs, right? Well, it's really how they come into play into SLAs. Again, golden signals track important attributes of a system from a user's perspective. These attributes are likely very similar to the attributes that you already use in your SLOs and SLIs. So in that regard, they can very easily act as SLIs and just slot into your existing SLOs. And frankly, you might even be tracking golden signals already. These aren't like super specific metrics. They're kind of generic to all systems that we use and that we run. But it's really up to the teams, the service owners specifically, to determine the acceptable ranges of these golden signals. Like for example, with latency, for one team running a streaming service, like a video streaming service, 1 second might be acceptable. But for an e-commerce shop or let's say a live streamer or a gaming platform, 1 second would, scare away all of their customers. So choosing these thresholds and these SLOs is very business dependent, but the metrics themselves, we believe, are fairly universal to all different organizations, regardless of the type of service that you're running. All right, so how do you actually bridge these golden signals in these SLIs together? And more importantly, why should you? Well, again, both are designed to measure important attributes about your systems. Both are meant to be really solid indicators of the end user experience and what your users are experiencing when they use your software. Both can tell you if your systems are performing well or at risk. That could be at risk of poor performance, of high latency, or of unreliability and even downtime. And a lot of them overlap anyways in the metrics that they measure. Right? Latency is kind of as an example, I'm just picking on latency. It's kind of a broad idea, right? It could be latency of HTTP requests, of REST requests, but it's really up to how your users are using your system and how latency affects them that you want to be looking out for. And if you already have a decently mature observability practice in place, there's a good chance you're already measuring this, just maybe not in the exact same way as it's defined in the golden signals category. So that's why it's important to, as you're thinking about how you can integrate these golden signals, to go over your existing SLAs, SLOs, and SLIs, and see if you have, see if you're already tracking these metrics. So as kind of like a step-by-step way to start thinking about this, start by identifying those SLIs that already represent those golden signals. So again, say you're tracking HTTP response time for a service. Well, that is effectively latency. So in a sense, you are already tracking that golden signal. If not, think about creating new SLIs and observability tool, or rather monitors in your observability tool to track the other golden signals that you're not currently tracking. So that way you have full coverage of those essential measurements. And then from there, based off of your SLOs, or if you need to, based off of your SLAs, start to set appropriate warning and alert thresholds for those SLIs based off of those. And as an example, off to the right, picking on Datadog again, for one of our test services that we call the ad service, we set up a golden signal to be able to track its latency and to be able to tell us when it's at risk. And this is just helpful, even though this is a test system. It just gives us really good insight into how the service is performing and if it's at risk of failing, if we need to go in and reset it, or if we need an indicator that the experience, that the load times might be slower than we expect. And even for this particular ad service, we also have the other 3 golden signals set up as well. So it's not too difficult to get these set up in your monitoring tool of choice. Again, we just picked Datadog because we use it a lot, but this just gives you a good example of what you can expect when you have that set up and how you're able to monitor it. So let's say that you've got your SLO set up, you've integrated the golden signals, you've got your monitors going. How can you use that to make sure that you're meeting your SLOs, not just the first time after you implement it, but continuously as you keep building out your systems and deploying new changes and expanding out your software stack? In short, how do you achieve success with everything that we just talked about here? No, the obvious answer is keep your systems reliable, but that's kind of a vague answer. And frankly, reliability can mean a lot of different things to a lot of different teams. So we recommend really starting with three sort of to-dos or tasks to focus on. First is creating a standard definition of reliability and having a centralized way to track it across the organization. Although every service is different and has different requirements for reliability, we really do need a way to measure and track reliability in a way that's fairly universal across those services. This means being able to set a standard for all of our teams and also having a way to track adherence to that standard, whether that means using metrics or dashboards or another type of system. Next, we need a way to track adherence to our SLOs. This means using our observability tool to its fullest by tracking our SLIs and then setting up monitors to alert us if we exceed or even get close to our SLOs. Ideally, we would set up some preemptive warnings to let us know that we're approaching the outside border of our SLOs. The good thing is that a lot of enterprise observability tools like Datadog, like New Relic, can trigger monitors based off of gradual trends and sudden rapid changes as well. Like they use some fancy AI to figure out what the general trend line of a metric looks like. And as it gets closer to that top threshold, we can have it send us a warning so we could at least get a little bit of an advanced notification to avoid a larger scale outage. And then with that in place, we want to be able to run regular proactive tests on our services to check their reliability and make sure that they can meet, or rather, make sure that we can meet our SLOs before an alert ever gets fired or before anything ever actually goes wrong with our systems. And setting up these monitors and alerts gives us fast feedback on changes to our systems, but they are also kind of a reactive measure. We want to be able to take a more proactive approach. And that's really where this topic of reliability testing and reliability management become relevant. And I'll dig a bit more into those into the next slide too. So what does this idea of reliability management or reliability testing look like? And the way it works is pretty simple. First is creating a baseline, using those golden signals and those fancy new monitors that we just set up to monitor them. We get a baseline of our service. And essentially, this is what good looks like in our environment. In other words, like what our team considers a healthy service. It's what our service is like when there isn't a lot of traffic, when it's running optimally, when it has enough capacity to scale, essentially when it's not in production, if that makes sense. We really want to get a baseline because we want to know what good looks like and the type of bar that we want to aim for, even as customers start using our service and putting load onto it. Next, we want to be able to test the reliability of the service and also look for reliability risks. Think about issues with auto-scaling, issues with redundancy, or even issues related to our dependencies failing. And having a set of reliability tests that we can run on each service, especially a set of standardized tests that are universal, not only does that make it easier to test an entire environment, especially if you have a big engineering organization or a big team, but it also gives you a standard baseline for comparing services to each other. In Gremlin, our approach to this is that we assign each service a score based off of the results of the tests that you run. And this score is universal across all the different services in your team. So if one service scores a 90 and another service scores like a 40, it's a pretty clear indicator that one is relatively less reliable than the other. And that's really where the standardization comes into play, is being able to create that sort of even playing field for comparing your services. Then, once you've identified those risks and hopefully address them, try automating these tests. Right? Our systems change constantly, sometimes many times a day. Think about companies like Facebook, who have like thousands of teams that are constantly pushing changes. All of them could probably affect reliability in some way. So just like you would run QA tests or integration tests on a regular basis, you also want to consider running reliability tests. And again, particularly in the case of SLAs, this is just to help you make sure that your systems are continuously meeting your SLOs before you have to worry about a violation or before a violation ever happens. This way, this proactive practice, yeah, that was a tongue twister. This proactive practice lets you stay ahead of risks and address them without ever affecting your customers, which, again, the business side of the organization, the side that created your SLAs and wants to please your customers and keep that income stream going, will absolutely love. And so I talked a bit about the score that Gremlin generates, and kind of wanted to dive into it a bit deeper, not just to tell you about our product, but just to tell you about ways that you can think about this and how the sort of standardization makes it a bit easier to test and improve reliability in your services. So Grumman created this idea of a reliability score specifically for standardization and to give a proactive way to measure reliability. And so we really encourage running the reliability tests that we create, that we predefine for you on your services, and using your golden signals as a way to monitor your services during those tests. We actually allow you to link your golden signals directly to our platform, and we're able to monitor them for you while you run your tests. So let's say you run a test that simulates a redundancy failure, such as like a node failing or a zone failing. If we see that your error rate golden signal has exceeded its threshold or has suddenly jumped up, we'll know that that indicates that your service isn't exactly resilient to that type of fault. And then we'll immediately halt the test and roll it back and mark it as a failure. So you know that that's something that you need to go dig into deeper and ideally rectify before you decide to deploy to production. Because it paints that as a potential area of risk that could affect your customers if you were going to have a host or a zone failure in production. And in the case of Gremlin, we categorize our test across 4 categories. One is auto scaling, testing that your system can provision new instances when CPU or memory is stressed. We also do redundancy testing, again, to make sure your system can withstand the loss of a host or an entire zone. And we also test dependencies in 2 ways. What happens if a downstream dependency if an upstream dependency has significant latency, or what happens if you lose that dependency altogether? So think about a web service that communicates with a database. What happens if that database is slow or unavailable, or you can't make a connection to it, or the connection gets cut off midstream? Does your web service keep operating reliably? Does it display an error message? Does it have timeout logic? Or does it just crash? These are all questions that are fairly hard to answer unless you're able to run reliability tests and use a standard measurement like a golden signal to make sure that your systems are healthy throughout that test. And so that's reliability testing on a per service level. And I kind of want to talk a bit about what this looks like at scale, especially when you have like dozens of teams in an entire enterprise organization and you're managing multiple SLAs or SLOs. So as a first step, you can use that score that you've created and assign to your services to manage your teams more effectively by using standards. You can do things like reviewing changes to the score, seeing how teams are scoring relative to one another, identifying risks, and think about the improvements that you can make. Think about this in comparison to the retrospective meetings that a lot of teams run after incidents have already happened. This now gives you, instead of a reactive approach, a proactive approach that lets you plan on what to improve instead of just focusing on what to fix after something breaks. The next step is to automate. So once you begin passing those tests and you're feeling confident about your services, you can schedule these reliability tests to make sure your services are continuously validated, even as your systems change, as engineers push new features or deploy new infrastructure or change the environment. You can also consider running these tests automatically from something like a CI/CD tool so that your services are validated on each change, kind of like how you would with a unit test or integration test. And then lastly, we can use the reliability score to even do things like block unreliable code from reaching production. You can imagine if your team or your engineering organization had a condition where you wouldn't be able to deploy new services or changes to services unless its reliability score is above 90 or 80 or some other threshold like that. This would really shift the attention to fixing reliability issues before deploying. Or if there was a situation like a bad code causing one of our reliability tests to fail in staging or in pre-production, we could prevent the problem from reaching customers altogether and in turn avoid a potential SLO violation. And we wouldn't even impact our customers at all because all of the testing and the remediation would have been done before going into production. And really, we think there's a lot that you can do with this score and with the standardization to improve reliability. But these are just 3 of the ways that we see it at Gremlin being used at high scale, high velocity team. So I know I definitely covered a lot. I'll just do a recap of what it is that we talked about. So again, SLAs, service level agreements, are business tools, but ultimately rely on technical metrics called service level indicators, or SLIs. Fitting into those SLIs are golden signals, which are 4 metrics that represent really the most important attributes of a system, particularly from the user's perspective. These golden signals represent key user metrics that are really invaluable to understanding how our systems, or rather, how our users are experiencing the systems and services that they use. So that makes them very easy to interchange with SLIs. And then also, the best way to ensure that you're meeting your SLOs and that your SLIs are in a healthy state is to run these proactive reliability tests. Use standardized reliability measurements to compare your services, and then automate tests, either by running these tests on a regular schedule or by integrating them into your CI/CD process so that they're run for every change that you deploy. So that way, you're making sure that anything that has the risk of affecting a service's reliability is caught and managed before it ever reaches production and has the potential to impact your customers. Also, just wanted to point you all to a few additional resources that I think are super valuable and I recommend checking out if you have the time. We do offer a deeper introduction into reliability management and reliability testing and all this stuff about scores and standardization. We offer a lot of additional information about that in an ebook, which we call Closing the Reliability Gap. If you want to check it out, it's available for free at this URL, gremlin.com/close the reliability gap. If you want to actually get more into the golden signals, we also offer a white paper that covers a lot of the same information that you saw in this webinar. And that's at gremlin.com/success with golden signals. And again, I have to promote Google's SRE handbook just because it's so good and it has so much good information, and because Google is such a leading force. Well, frankly, they sort of define the industry of SRE. So I highly recommend checking out the ebook. It's available for free. It's fully online. Make sure you check out chapter 6, which is on the golden signals. But there's a ton of other good info in there. So if you can, head over to sre.google/srebook/table of contents. I think I'm missing a .com there, so sorry if that URL is invalid. But Google it, click it when it comes up, and give it a quick read, and you won't be disappointed. So that's all I had for you today. I'll actually hand it back over to Jeannie to do a wrap up, and then we can do Q&A after. So back to you, Jeannie.
All right. Thanks, Andre. Appreciate it. All right. So that is the end of the presentation portion of today's webinar. If you haven't already, please put any questions you have in the Q&A panel. All right, let's get started. All right, this is a bit of a long one. On the SRE book, it mentions that measuring CPU usage is not actually the best way to know if a system is working or not, because maybe that service is running on a scale set or something similar. So how is saturation different than CPU/memory usage?
Oh, that's a good one.
Did you get all that?
Yeah, I did. Thanks. So yeah, it is a good question, especially when you have a system that auto scales, because if you use 100% CPU and the system scales, then that metric becomes kind of meaningless. So really what it comes down to is, I think the focus personally is more on memory, because if memory gets too full, you actually have the chance of the system really becoming a lot more sluggish, or there's the possibility of processes crashing. But kind of on that same note, if CPU is too high, then there is that risk that process won't be able to run quickly. So even though CPU usage isn't actually the best way, when you use it within context, then it really does become a good indicator of where you might be hitting your performance limits or your scaling limits. So the way I recommend trying that out is, run a test or some sort of stress program that uses as much CPU as it can, like that 90% or 100%, and then keep an eye on your systems to see if they actually scale. And if they do, then that's great. That means you can be able to add capacity as needed. But if not, even if your systems don't fail outright, there is still a big risk there. So you should still look into scalability if that's the case.
Okay. Next one. Are there any new Gremlin features related to this topic? And no, that is not a seed question, people. That is from Alberto. So I just want you to know that's real. All right, Andre, go for it.
Yeah, I mean, I could talk a whole lot about that, but we did launch a new platform that's called Gremlin RM, Reliability Management, and it really pulls in this topic of golden signals and also standardized testing. The way it works is that you add your services into Gremlin. You tell us what your services look like, what host it's running on, what Kubernetes services it's running on, and then you also link into your golden signals for that specific service. And then from there, we generate reliability tests that you can very easily run on those services. And as the test is running, it monitors your golden signals to make sure that your systems are still good. If they are, then the test passes. And if they're not, then the test fails. So from there, you're able to not only see which parts of your system need more attention and which ones are good to go, but you also get that standardized score that I was talking about. So you can compare all your services on a 0 to 100 level.
Okay. Next up, what thresholds do you recommend setting for SLOs for a team that is just starting out?
So that depends a lot on, well, I'll start by saying that unfortunately I can't give you specifics, but it depends a lot on different factors, like the type of service you're running, where you're running it, like what cloud platform, and even how quickly somebody in your team can respond to problems, like your on-call rotation. Really, the most important question when you're thinking about this is how much downtime or slow performance are your customers willing to tolerate? What's their threshold for what they're, willing to put up with, basically, when using your services? And then that should really define the maximum allowable limit for your SLO. So you can define your SLIs and your golden signals and everything around that. So again, start by thinking how your customers use your product, what their expectations are, what gets them frustrated if things are slow, and then work on your SLOs from there.
Okay, great. This next question. This makes it seem like you have to use golden signals in your SLAs. True? Question mark?
As a Gremlin representative, I probably should say yes, because we have you use golden signals in our product. But honestly, it's not necessarily. Golden signals are really, I hate using the word generic, but they are kind of generic, right? They're interchangeable with, any sort of monitored distributed system. But realistically, what works for one team might not work for another. Keep in mind, too, that these were created by Google, and very few companies operate on Google scale. But honestly, I think that for most companies, they provide a good enough baseline of what to measure that, it's kind of like the Pareto principle, 80-20. These will work for 80% of the teams that use it, and the other 20% might need some more advanced or in-depth monitoring that they can set up themselves.
All right. All right, looks like we're on to our last question. So if anybody has anything that they haven't put into the Q&A, please do that now. All right, last question. We already have observability in place. Should we still go back and add the golden signals if we're already tracking a lot of per service metrics?
I say that if you've already got like a decently mature observability practice in place, then chances are you're already tracking at least some of the golden signals. Regardless, though, I do still recommend going through and reviewing the monitors you have set up in your metrics just to see if there are places where you can add them, because they do still add valuable insight. And you just want to make sure that you have that full visibility into your systems if you can. I know that a lot of cloud monitoring services can get expensive as you collect more data, but especially if you've experienced an incident in the past, having that insight can be super useful.
All right, we did have a last minute question, and I'm going to hopefully get this all right. Okay, today it is very common to have several parts for a single solution / app, front end, database, platform as a service, infrastructure as a service, K8s, Redis, cache, etc. How do you measure golden signals in that case? There's a couple other follow-up questions, but I figure I'll leave it with that first question.
Yep. I actually saw it come through.
Okay, good thing you won't make me read it out.
All good. So that's a very interesting one, because you have these big distributed systems with all these different services in place. Ideally, I would say just put the 4 golden signals in each part. So each of those individual parts and surfaces that you have running, especially if you're using like a genuine pure microservices play where you have each team responsible for one or more services, I'd say then you definitely want to have the golden signals on each individual part. But if you think about how your application functions and the different sort of units of functionality that are in place, it's like, for example, if you have, I'm trying to think of a good example. Let's say you have your Redis cache and one Kubernetes deployment that talks to it. Then you might want to create golden signals for that unit as a whole. You could do that, but again, it really depends on how your application is architected. But I say the easiest way to go, the best way to get started is to just set them up for each individual part.
All right, it looks like that is the last question. So we're going to give you folks plenty of time back in your day. Thank you very much for joining us. Look for the recording in your email inbox shortly. As you exit today, you'll be asked to complete a brief survey to help us continue to deliver quality educational webinars. We appreciate your feedback. Thank you for joining us and have a great day.
Thanks, everyone.